All right, here's 2.4 day 1. The goal in all of 2.4 is going to be to find minimums and maximums of polynomials, but we're going to split it up from one day to another by the type of polynomial that we'll work with. Today we're finding maximums and minimums, and we're just going to work with quadratics. Okay. Again, that is a polynomial that has degree 2. So the highest power that we could see x raised to is 2. Okay? Now this is not brand new for us because we did an entire unit where we just looked at quadratic functions. The maximum or the minimum is at the vertex. We can find this by taking negative b over 2a. And again, those parameters for a and b are referring to a quadratic that's in standard form, where a is the coefficient in front of x squared, b is the coefficient in front of x. Okay? If a is a positive number, we have a quadratic that opens up, and that vertex is a minimum. If a is negative, that's a quadratic that opens down, so that vertex is going to be a maximum. Okay? Again, this is not, what we've seen on this slide is not new by any means. Okay? We covered this in our unit, and we saw questions like this. All right? What kind of function is this? Well, it's got this term right here with an x squared and no term that's higher, so this indeed is a quadratic. A is 2, which is positive, meaning it opens up, and this is a minimum. Okay? The x coordinate for that minimum is going to be negative b over 2a. B is negative 6, so negative b is positive 6 over 2 times 2, which is 6 over 4, or 3 over 2. Okay? Now if we wanted to figure out the other coordinate for the y value, I would do g of 3 over 2 plus 9, and that is how we would figure out the y value. Okay? Whatever we get from that, from evaluating at x equals 3/2 would give us our y coordinate. Okay? Again, none of that is new stuff. This next part will be. Okay, let's take a peek at what kind of questions we can answer by calculating a vertex. Now this is the kind of stuff we did not really get into this in our quadratic unit. Okay, kind of a cool question here that we can take a look at. You got 60 meters to build a fence for a dog. And what you're going to do is you're going to build 3 sides up against a barn, so you don't have to build the 4th side. Okay? And you're trying to figure out the dimensions of the pen that will give us the biggest area. Okay? Now, first, if you were to read this question, you may not feel like it's about a quadratic, because it's at first it looks like it's an area question. All right? But here's where the quadratic comes into play. Our dimensions are variables. Okay, so what should we make the width of the pen? We don't know. At this point in time, we'd have to just say x. We have to choose a length. Okay? We don't know that at this point in time because knowing what the width should be will actually be the end result of the problem. Okay? For this 3rd side right here, the length. All right? If we had 60 meters to begin with, and we build one side that's x, and we build another side that is x, whatever is left over is what we can use to build the 3rd remaining side. Okay? Now this, if I wanted to simplify it, would be 60 minus 2x. Okay? Again, I'm coming up with an equation here for area which is length times width. Now, I don't know what the dimensions I should choose, so I have a variable, but I'm saying that the dimensions of this dog pen are x by 60 minus 2x. Okay? This is where it comes back to a quadratic. This formula for area, after I FOIL it, excuse me, not FOIL, distribute, okay, would be 60x minus 2x squared. And this right here is a pretty powerful tool to try to figure out this problem. Is I have this function, which is a quadratic, okay, from doing the x times x. I got x squared, so it's a quadratic. And I can use this to just enter a length, or a width, I should say, for x. And as an answer, this will tell me the area. Now what I can see from just the equation in this first term for a, which is -2, this is a quadratic that opens down, which means as I start to pick bigger values for the width, the area goes up and up and up and up, and then it reaches that vertex, okay? And that point right there would be the maximum area. That's the point I'd want to know. Well, I have the equation for it, and I just have to figure out where is that point? Where is that maximum point? And again, I can figure this out using -b over 2a, just like I did on the previous slide. Here, b is 60, so it would be -60 over 2 times -2, as a is -2, which would be -60 over -4, or 15. Okay? We should make it 15 meters wide. Now going back over here, 60 minus 2x. And notice, I'm trying to get the length right now. I'm not going back to the area formula. I'm done with that because I found the vertex and figured out that the width needs to be 15 meters. Okay? So right here, 60 minus 2 times 15, that equals 30. 15 plus 15 plus 30 adds up to 60, so I've used all my fence. So for the final answer here, this pen should be 15 meters by 30. That will give us the biggest area possible if we had 60 meters of fence. Okay? Here's another one. Alright, this one is just about a rectangle here, but the only difference is that we have the perimeter, which is 100 centimeters, and we're going to set it up very similar. But here it's saying in this rectangle that we're going to build all four sides. If we think about it and relate it to the first one, okay, we're going to construct a rectangle that has the biggest area possible, but we're constructing all four sides. Okay, so let's start in the same place. Let's say the width is x. Okay, I've got 100 centimeters to work with. And this was the point on the previous problem where I would have said, okay, for this remaining side, it's got to be 100 minus 2x. But the thing is here, I now have to build this side and the fourth side. So whatever is left over after I pick the width, that needs to be cut in half because I need to use it for this side and the other side. Okay, now I can simplify this a little bit, and I can make it 50 minus x, and then over here, it would be 50 minus x as well. Okay? At this point, I would solve it in virtually an identical way. I've got this rectangle. Its dimensions are going to be x times 50 minus x. Again, that's for the length and the width. I could distribute this a bit and say 50x minus x squared, and I find myself in the exact same spot. Okay, I've got this quadratic where I can just plug in, not not any value. This kind of gets back to the domain. Given that I have 100 centimeters to work with, I'd have no business looking at x values that are outside 0 and 100. Okay, no business outside 0 and 100. Well, actually, see, if you really got down to it, I really should only be looking at x values from 0 to 50, because I would have to build multiple sides. So I couldn't use more than 50 on any given side. So it really should just be 0 to 50. But this is the point once again. I go to negative b over 2a. Negative b is negative 50 over 2 times negative 1. And it's 25. Okay? 25, 25. 50 minus 25. This would be 25. And the same over here. One observation here between the two is that on the previous problem, when we built the 3 sides, it didn't come out to be a square. It actually came out to be a rectangle where the length was twice as long as the width. Okay. Here we were building all 4 sides with the same goal of maximizing the area with a set perimeter. This one did. This one did come out to be a square. Interesting to note the difference. Solved the same way, an application of finding the vertex of a quadratic, but slightly different situations with building 3 sides on one and building 4 sides on the other. One led to the answer of a square, and one did not. Okay, and we'll see in class when the assignment and whatnot, a few other kind of derivations of this kind of problem, where once again we'll kind of get slightly different results. Because I think on one sense you might think, well, every time it's going to always come out to be a square. Well, not always. And like we saw in the last example, that's not always the case. Okay, we'll look at more of these in class. Obviously, if you have any issues with this, let's talk more.